Hello, welcome to this video. In this video, we'll be looking at rates of chemical reactions in chemistry. We'll be looking at rates of chemical reactions. Now, what are rates of chemical reactions? Rates of chemical reactions, that is just a rate. You can say it's a speed at which a chemical reaction takes place. Now, a rate can be affected by different factors, which we are going to talk about. Now, chemical reaction is a rate of a chemical reaction is. So like we are saying, it's a rate of change of an amount or concentration of a reactant with time. In terms of symbols, you can say it's a rate of a chemical reaction. You can say R is equal to the change in the amount of a substance, such as concentration. Concentration, we will use these symbols, over the change in time. So this rate, it can be, for example, let's say the change in mass over the change in time. Let me just give an example. This is a curve, and the rate of this reaction is going like this. Okay? And this is time, and this is mass. So we have the final mass there. Let's call it 6. Sorry, not 6. Let's call it 2. And we have the initial mass here. Let's call it 6. Then the time is 0 here. Then let's say if the reaction ended somewhere here, let's call it 4 seconds. So in this case, our rate of reaction will be equal to the change in mass, which is M2 minus M1 divided by T2 minus T1. And the rate will be M2, if you want to get pick this, which is 6 minus 2 over the 2 is here, you are getting. While the time is 4 minus 0, which will give you 4 over 4. And your rate will be equal to 1. Mass is kg, so kg per second, like that. That will be your rate. So that's just how we can find the rate of a chemical reaction. Let's look at factors that affect the rate of a chemical reaction. Let's look at the factors affecting the rate of a chemical reaction. The first factor that affects the rate of a chemical reaction is temperature. Now we know that when we talk of temperature, we are talking of the hotness or coldness. Now, how does temperature affect the rate of chemical reaction? They are saying at higher temperatures, so when the temperature is high, what happens? The rate of chemical reaction is high. Why? Because since when the temperature is high, the particles have more kinetic energy. Particles have more kinetic what? Energy. Now, since they have more kinetic energy, they collide frequently. As they collide frequently, they gain speed. In the process, speeding the chemical reaction. Speeding the reaction. That is when the temperature is high. When the temperature is low, it's the opposite. The particles have less kinetic energy. They can't collide frequently because there's no effective collision. Hence, the reaction is slow. Let's look at concentration. Now, how does concentration now affect the rate of a chemical reaction? We know that concentration deals with the number of particles. Deals with the number of particles. That's what concentration is. So, at high concentration, we are saying there are more particles. Now, since there are more particles, according to the law of effective collision, the more the particles, the more they collide. So there's effective collision taking place here. Effective collision. Effective collision. Now, since there's effective collision taking place, what happens? The particles are moving with a high speed. Hence, the chemical reaction is fast. But at the concentration where it is low, what happens? The particles, they are few. Hence, they are like distanced from each other like this. So for them to collide amongst one another, it's taking time. Hence, the reaction is slow. Out of pressure. Pressure only, and I'm repeating, only affects reactions involving gases. That's all. For example, if I say the reaction between nitrogen and hydrogen to form ammonia, all these are gases, even ammonia is a gas. So this reaction can be affected by pressure. Now what happens? When there is a high pressure, it results in a high speed. When you increase the pressure of nitrogen here, what happens? The particles in here, they collide frequently. It results in effective collision, which are going to react with hydrogen here to form ammonia. Hence the particles, they collide and they move very fast. For example, when you put particles in a small container and when you put particles in a big container, the volume here is more as compared to the volume in here. So the volume here is less, while the volume here is more. So the lesser the volume, the more the pressure, because the particles will now be exerting more pressure on the walls of the container, unlike here. Light intensity. How does light intensity affect the rate of a chemical reaction? What happens? So when there's high light intensity, the particles, they gain more kinetic energy. So they gain more kinetic energy. When they gain kinetic energy, they are going to collide frequently or effectively. Now once they collide effectively, those particles, they are going to speed up the rate of a chemical reaction. At low light intensity, it's the opposite. A catalyst. How does a catalyst affect the rate of a chemical reaction? A catalyst has no effect on the chemical reaction. Has no effect, but it lowers the activation energy. The activation energy, by this symbol, is the energy required to start up a chemical reaction. That's what activation energy is. The energy, the maximum energy required to start up a chemical reaction. So a catalyst really has no effect on the chemical reaction. It only lowers the activation energy. That's all. I forgot one more factor, which is the factor of surface area. I forgot that one, so okay, I'll just write it there down. Another factor, factor number 6, is surface area. So I'll say surface area. How does surface area affect the rate of chemical reaction? When we talk of surface area, we are talking of how many particles are present at a certain volume. Now, surface area has to do with the particle size. If the particles are large, let me say this, and with these particles, when they are like this, you discover that, let me call this one 1, let me call this one 2. You discover that 1 has surface area, a low surface area, while 2 has a large surface area. Let's call this one small. While this one has got large surface area. So the particles are very small. I'm sure you can see they have been clashed. Hence it has got a very large surface area. Because the particles are small, these particles will be able to collide against each other more frequently than these, because these need more energy. So increasing the surface area, like in this case, it increases the rate of a chemical reaction. While when you reduce the surface area, like in this case, you are going to reduce the rate of a chemical reaction. So thank you so much. I'm Previous Tutor. I'll see you in the next video.